Okay, so first thing that you should always do is connect the resistor, because resistor is a component that has no polarity, right? There's no negative or positive terminal. So we can connect the resistance with any side. So 1, 2 or 2, 1, it doesn't make much of the difference. It doesn't make any difference. Okay, 1 and 2, okay. Now just notice that there is no battery in the circuit. Okay, you don't need to connect that. Now any component that you will be connected in series with resistance would going to be connected here on these green points, these green dots, because these columns are vertically connected. Remember, we discussed about it. So any component, let's say if we are going to connect the positive leg of your LED with the resistance, so these green points are the point where you are going to connect that. Okay, that's important. Now always remember, you cannot connect your resistance this way, this vertical way, because this prototyping area, the columns in this area are vertically connected. So if you connect the resistance this way, there is no resistance introduced into the path, because these are already shorted, so resistance is bypassing. Okay, so this is not effective, so this is not required. Don't do that. They short, right? Likewise, if you were to connect a resistance in the power bus, you cannot connect it horizontally, because this horizontal bus, this power bus is horizontally connected, right? Now connect the LED after resistance. Okay, now LED, be aware that LED has a polarity, right? This LED has a positive and negative leg. So although resistance has no polarity, so you don't need to worry much about it, but resistance you have to be careful. This is my positive and negative leg of my LED. So here is a diagram of LED, and there is a way to identify the polarity of LED, because you don't know what is the positive leg and what is the negative leg. So there is a word of advice here. Always, if you are unsure about the polarity of LED or any component for that matter, if you want to see any technical parameter of that component, the data sheet of that electronic component is the best way to go about it. Okay. Now manufacturer normally always gives you a hint that which one is positive and which one is negative. Normally what happens in case of LED, that the larger leg is the positive and the shorter one is the negative. Okay, the positive leg has the long leg, the positive terminal of LED has a longer leg, and negative has a shorter leg. Okay, now another thing to notice, that once you connect this LED on your breadboard, now after getting connected on the breadboard, there is no way to identify which leg is larger, which leg is shorter. In that case, you can see at the plate, the larger leg has a shorter plate, okay, and the shorter leg has a larger plate, as you can see in the diagram here, right here. This is the shorter leg, but it has a larger plate, right? Now this one is the longer leg, but it has a shorter plate. That's a way to identify it. Okay, a smaller plate like this, shorter leg, negative has a larger plate, right? Like this. Now the positive is called anode and negative is called cathode. Okay, there are two arrows going outside, because this is my light emitting diode, right? Light is being emitted, that's why there are two outgoing arrows. Okay, now this is how your LED is going to be connected with your resistance. Okay, now the second end of your resistance should be in the same column as the positive leg of your LED. Okay, this is important, because then only your resistance is going to be connected with the positive leg of your LED. Okay, so let's say this is my point number 1. point number 2, 1, 2. The second point of resistance is going to be connected the positive leg, okay, so which is on the same column, okay, same column. The negative end of my LED is going to be connected here, okay, on this bus, okay. Now after you have connected resistance and LED both, then it's turned to connecting the power supply, okay. Now connect the positive to the first end of your resistance, and that way, and the negative is going to be connected to the ground or negative terminal of the battery, okay. Okay, so the positive of the battery is denoted by color red, and the ground or negative is that by black, okay. Now in the circuit, the positive supply, which is denoted by this red color, is connected to the point number 1 of my resistance, and the point number 2 of my resistance is connected to the positive of my LED, okay. And likewise, the point number 3, which is the negative of LED, is connected with the ground, right, which is denoted by this blue line, okay. Okay, now here on the breadboard, as you can see, the positive is extended to the prototyping area by this red tapping here, right? And this is connected with this green colored column, which is vertically connected and which is where the resistance is connected, right? That's way the first end of your resistance is connected with the positive bus, okay, and the second end of your resistance is connected with the positive of your LED, right here. This is the second end of your resistance, the positive of your LED, okay. Now the negative leg of your LED is connected with the ground, right, which is denoted by this black color, right. This is the ground, the ground. Now this breadboard view diagram is I made it using the Fritzing software, which is available for free on fritzing.org, www.fritzing.org website. You can make this diagram using that. It's super handy and super useful software, and I would strongly recommend using that because if you want to create the beautifully and most explanative kind of diagrams, so Fritzing is the place to go for, okay. All right. Now there is one more efficient way to connect the same circuit as we just saw, okay. Now here's my 9-volt battery, and this is connected through the power bar, okay. Now the resistance, the first end of my resistance, is directly connected to the positive, as you can see here in the diagram, right, and the second end is connected with the positive of my LED, okay. Now just notice that the second end of my resistance and the positive end, they are connected on the same column because they are vertically connected. I have been repeating this again and again because I believe this is important, okay. Just bear with me if you find it cumbersome or too much repetitive, sorry about that. And the negative is directly connected to the bus, okay. All right, so in my last video about the breadboard, I did not mention about the full-size breadboard. The breadboard that we covered in that lecture was the half-size breadboard. Now typically breadboards are two types, either half-size or full-size. Now there are small breadboards also available in the market, but we are not covering that. Typically breadboards are either half-size or full-size, okay. Now the full-size breadboard, what's different in a full-size breadboard is that there are 10 pairs of 5 holes each in the bus bar section, okay. And in addition to the horizontally separation which we saw there in our half-size breadboard, full size breadboard is also separated from the midway vertically. Okay, so from point number 5, this breadboard is separated. Now, this blue bus and the green bus, as you are seeing in the diagram here, these two are horizontally connected, but they are not connected with each other. They are separated from here. Okay, so that's important to notice. The rest, everything is same. Okay. Okay.